Okay, now we have the what is called the power property of logarithms. Now that's cool because like logarithms are a way to rewrite um, exponents to begin with. So what happens when we take a log of a number raised to a power, a number that has an exponent? Well, here is what we can do. It's the same thing as n times the log base b of m. So this is actually probably one of the cooler ones, one of the more useful ones in terms of simplifying logarithms. So let's try it out. All right, we have 5 times log base 4 of 2, and we want to condense it into a single logarithm. Okay, so notice we have the number being multiplied to the logarithm. We can transfer that number over as the exponent of 2. So we're going to have log base 4 of 2 to the 5th power. So the 5 is going to move over as its exponent. But 2 to the 5th power can be simplified. So you have log base 4, 2 to the 5th power is 32. So it's really log base 4 of 32. So not such a crazy problem, and can be very handy. So let's move on. Same idea. Move the 7 over as the exponent. So we have log base 2 of x to the 7th power. And we cannot simplify anymore, so we'll leave it like that. Alright, now fractional exponents, always kind of a pain, but still, we're just going to move it over. So base 10, so it's the common log of 8 to the 1/3 power. Or, more commonly, we would probably express this as log of the cube root of 8. So this is how we can sort of simplify some of these problems. Now let's look at how we could use these problems to expand. So let's perform an expansion and simplify if possible. So we have the 7 as an exponent. We're just going to move the 7 as the product. So 7 times log base 2 of 8. Now, we could, simplify this a lot further, evaluate it even. Log base 2 of 8 equals some value x, is saying that 2 to the x power is 8. Then that would mean x is equal to 3. Because 2 to the 3rd power is 8. So, log base 2 of 8 is 3. So this is really 7 times 3, which is just 21. But just remember the important part, which is you can simplify it like that. Continuing on. Alright, now we got this craziness going on. But still, move your exponent. Put it in parentheses if you have to, but you're moving your exponent as a product. So we will have 3, keep the 3, times x minus 1 times the common log of 4. So then you would just, expand that way and but make sure when you do this you keep it in parentheses. So we have 3x minus 3 times log the common log of 4. And that's going to be your simplified version. You still want to treat that expression 3x minus 3 as a single thing. Just that's the way the logarithms work, because if we were to simplify it again, we would want to put that entire value in the exponent if we were going in reverse direction. Anyway, so, alright, log 7 of the square root of w. Well, it has no exponent right now, but the square root is a fractional exponent of 1/2. Move the 1/2 to the front, we get 1/2 times log base 7 of w. And that gets us our answer. So these are the ways we can expand and condense logarithms using this is the last property we're going over today, the power property, but it's definitely a very handy tool when you start evaluating and solving some of these equations with logarithms later.